Hello everyone, and welcome to today's webinar, The Definitive Software Development Kit. Read all CADx interfaces with 3D Kernel IO. My name's Maria Ma, the Marketing Campaign Coordinator for Engineering.com, and I'm happy to welcome our speakers for today. We have David Solomon, Director of Sales at Core Technology. David is a subject matter expert with more than 15 years of global leadership experience in automotive, general machinery, and aerospace markets, focusing on CAD, CAE, and CAM. Also with us here is Michael Lambrick, Marketing Manager at Core Technology. Michael is a knowledgeable marketing leader with 7 years of experience focused on interoperability within the CAD, CAE, and CAM space. And last but not least, Damien Jemay, Head of Product Development for Core Technology. Damien leads product development for 3D Kernel IO, 3D Evolution, and 3D Analyzer. Now, before we get started, we just want to cover a few housekeeping items. Today's webinar will be recorded, then available for on-demand replay on engineering.com. For attending this full live session, you'll receive your PDH certificate within 48 hours. And if you have any questions, please submit directly in your webinar interface, and we'll try to address all questions during Q&A. Now, without further ado, I'll pass it over to our first speaker. David, over to you.
Well, thank you. Just a little agenda on today's meeting. You get a little introduction, which you received from Marie, and then we will have a corporate overview, about 10 slides on core technology and some of the things that will be not covered today's technical presentation. And then Damien will go into a technical presentation regarding the actual technology and implementing a software development kit named 3D Kernel IO. A little on the corporate overview. We were founded in 1998. We have over 85 employees. Our headquarters is the picture there. Pretty cool building. And then we also have our development center where Damien is located in our France and Morocco locations. And then we have locations around the globe. So product offerings on core technology, starting from the left-hand side, would be our 3D Evolution product. And that really is used at our end user customers like Fiat, obviously Stellantis now, Lockheed Martin, Airbus, just to name a few, and using it to handle the engineering chore in this space. So anything that you think of as a chore, from CAD translations to simplification, we've written scripts to develop into PLM systems. And then we have a 3D Analyzer, which is a visualization tool best known for visualization without translation. So it's not a requirement to translate to a PDF or translate to a JT. As an example, you just hit File, Open, and it's utilizing our kernel product that we developed. And then an additive manufacturing solution and innovative managing CAD data. So a lot of times in the additive manufacturing spaces, you deal with STL file with core technology on the metal printing and some of the other printing. You really want to do some direct modeling or changes to the model. So you read that CAD data direct. And then last and not least, and most importantly, is our kernel IO. And so when you think about CAD data and reading that CAD data into PLM systems and other solutions out there, a lot of companies have used our technology. Every time you hit File, Open, you're opening up the DLLs from core technology. And so what you'll learn from today's webinar is how other companies in the industry has used one DLL to read multi-CAD, any CAD up to a number of, I think, 30 interfaces. You'll understand the value of the different kernel operations and really the healing functions of how important it is to get a solid model when you're reading that data. And then also we'll talk a little bit about the parametrics and understanding how those fit into downstream applications. And just to name a few of the customers that are using our software development kit, MSC Software, Pointwise, which is now a part of Cadence, Altair is a big one, P&G actually. It's interesting to know that a lot of companies have gone out there and developed their own technology from a visualization point because of what is expected on the target solution, or what are they looking for those results of that data, whether it's attribute files or any other composite data that's not developed out in the industry. And so what kind of interfaces do we read and platforms do we support? You got Windows, Ledix and Mac from a platform support, and then the fully parametric, which is reading that CAD model as if you were reading it in the CAD system itself. You can see the listed, and then the BREP interfaces, and also you'll notice that Core Technology also supports saving of formats as well. So CATIA v5 without accessing the APIs of that CAD system, same with NX and SolidWorks as well. And so I want to touch a little bit about the key differentiators in the market. There are really only a handful of companies that have developed libraries out there and brought them out to the market, but we found that from a parametric reading, Core Technology holds the ability to read most of the data from the feature-based technology. Also, a lot of times when you're looking at reading the SDK or a kernel, you have to have that particular kernel, which is the Parasolid kernel. Core Technology reversed engineered that from the binary code, so you don't necessarily need that partnership with Siemens to read the XT, or if you will, the Parasolid. And then reading interfaces that are unique might be the V6, 3F, and the other ones listed here. And then I already mentioned the fact that we have the ability to write specific entities as well. So giving you the ability to use one DLL in the software. And then we have some additional modules that might be interesting. So if you really look at any data that's translated, maybe there's an interest in having a comparison or even understanding that backlash or a specific checker, whether it's a product data quality check or a tessellation check, which I think that Damien will go over a few of those interesting points in the market. And when we talk about feature base, again, more specifically, that feature base is reading the parametrics as you see it in the picture. So I'd like to actually have a poll question come up here.
Thank you, David. Attendees, please let us know, what kernel is your company's code developed in? Parasolid, ACES, or own developed kernel?
Yeah, I'd like to go ahead and ask the second poll question based on those comments, and I definitely appreciate that. Yeah, that's interesting. And then David can talk also when he gives his portion of it, the connectors into both the ACES and the Parasolid kernel for those 38% and 31%. And then also we'll talk a little bit about how the value added is on the feature stuff on the technical side. I think there might be some value in there. So the class reference is using the language just C, and the compiler is Visual Studio. One of the things is, I mean, the documentation is pretty self-explanatory. We definitely edit that from time to time, but we found what's most importantly is when you set up these reading capabilities, whether you're reading the Parasolid or the CATIA or the NX, is using one DLL makes a big difference, not only for the first implementation process, but more importantly, when we renew or give you new enhancements to the code, it's much easier to change that code. And so I want to talk about the best in class, what I consider our bug tracking system. So obviously there's new releases of software out in the world because of the bugs or enhancements that are brought to the product. And what we found is that on average, our bug response is within 36 hours at the time that it's reported. But more importantly, we really dive into your specific bug to understand if the bug is actually a bug in our software, is it a user error in configuration, or is it something that needs to get enhanced? And I think that's extremely important when you're working with a partner, is to be able, from a development side, talk strictly to developers versus application engineers. And then a little bit on the CAD Converter. A lot of times you may need to convert the data as you're using it in our software development kit. But more importantly, if you're using that Parasolid kernel, a lot of times that CATIA file is never going to come in as a solid model. Or even if it's coming from an ACES kernel like Creo, you're going to need to add some functionality in reading those CAD systems. And so we have this available. And I would say that this is a huge competitive advantage to Core Technology, because we've also added the VDA, the Sussex, and the LOTAR checker and quality verification and validation in our technology. And so those advanced tool capabilities will allow you to heal for a solid model, but go and understand the underlying math understanding the G1, G2 continuity or any twisted surfaces in the background that would cause a big problem when you're creating NURBS in the CAE space versus the CAM space. And then the step 242 has been widely used in the industry. So if you're interested in this, I could talk your ear off on this. I sit on the board of directors for PETA, so I help write the standards for the industry on ISO standards and understanding the value of reading that full assembly in a step file, reading both the geometry and the tessellated of mixed geometry for market-ready geometry. The PMI is big, right? So if you're taking that semantic PMI data and using that, and you're building an application that has to do with CAM versus having to do with CAD, you want that information out there. So a lot of folks are starting to use that step 242 format. And then allowing the ability in your own technology without having to develop a model compare tool is a big advantage. You just want the results of either the geometry or the assembly or maybe even the PMI or specific attributes. It's very easy to set that up in the kernel and have that done with the click of a button. And I think we have out of the probably 5 customers that are using this technology.
So I'm Damien Genet, I'm based in France. And in fact, I handle the technical aspect of our main products. So today we are going to speak about 3D kernel IO, which is our own CAD kernel, and which is sold into an API for company who develop softwares. I just wanted to explain how we work, because as you can imagine after David's explanation, we are able to read CAD formats like CATIA V5, CATIA V6, Creo, NX, etc. But you won't need to use the original CAD software. That means if you want to read and extract data from such files, you won't need to have CATIA or NX or Creo installed with their respective licenses. You just need to have a core technology license to use our product and to be able to get such data. What you can see on my screen at the moment is the API package, which is the latest version at the moment. And you will get some disclaimer, some release note PDF files, etc., which will explain the differences introduced in the new version regarding the previous one. One important thing is we avoid to do any change in our API. So when we want to improve something, we add a new function, or if we can't add a new function, we add a new parameter to an existing function, but this new parameter, we have a default value. And so on your side, if you rebuild your application which use our API, you won't need to do any change. You just need to update your header files, update the lib file, and update our DLL. Then you need to rebuild your application, which should go fine, and then you can run and use our new version. So this is something very important for us, because we know it's a real nightmare when upgrading API versions. And since on our side we release 4 versions per year, that means you have the major year version, which at the moment is 2021, which has been released at the end of January. And then we release 3 service packs among the year. So in such service packs, we fix problems if you encounter some or one or no. And also, very importantly, we also integrate the support of new CAD version when they are released. That's why, in fact, we release so much version per year, because we know that on your side, you need to be up to date, because we have some responsibility on our side when we provide this API to you. It's that your software which integrates our API should be able to load any CAD file that your customer has paid for. So that's why we do this. We have a documentation folder which contains a standard and technical Doxygen documentation, which is automatically generated from our header files, and it also contains a lot of sample source code inside. Then you have the source folder, so like for any standard API. This folder will contain our kernel.io header files. So such files contain all the functions of our library. And very important, we also provide a sample application. This sample application, we provide its full source code, and we try to nearly call all functions of 3D kernel.io. So it's a very good teaching example because we provide everything in it. And in that sample application, we do two major things, among others. We provide an XML export source code, which is quite big, as you can imagine. This source code, in fact, will browse all the data structure of 3D kernel.io and export all such data in XML file. So the other important thing for most of our customers is the OpenGL rendering source code. So in fact, this source code is quite similar to the XML export because it will browse our data structure, but it will browse only the geometry, and then for each faces, it will get all the triangles to do rendering. What you can see at the moment is we use OpenGL for the rendering, and we use Qt library for the graphical user interface of the sample application. We have done this because 3D kernel.io is available on Windows, Linux, and macOS. And Qt is also a graphical user interface which is multi-platform, and OpenGL is also multi-platform. Hence, this source code you can see on my screen works perfectly and in the same way on the three platforms. So that's why we have chosen such external library for the sample application. That being said, you have to understand that our API is free from anything. We own everything it contains, and so you don't have to rely on Qt or on OpenGL if you want to do any rendering. And in fact, we have a lot of customers who just built some command line utility tools to get exactly the data they want. Then they process such data in their pipeline to prepare their own formats, and then they can use all such data in their CAD software, or maybe not even CAD software, but any software. So that's why I just wanted to explain. We use Qt, but it's not mandatory. And same thing for the OpenGL rendering. It's only for demonstration purpose. And because also Qt and OpenGL are quite straightforward to see and to analyze their source code. And finally, we provide the binary. So you will get on Windows a small lib file. You will need that file to link an application which use our API. And on Windows, Linux, and macOS, you have the dynamic shared library. So on Windows, it's a DLL file. On Linux, it's a SO file, and on macOS, it's a dylib file. So our API is only, between quotes, it's only a 100 megabytes DLL. But remember, with this single DLL, you can load any CAD file on any computer without installing any other CAD software. So it's not so big, finally. And we provide a sample folder which contains a Visual Studio project on Windows, on Makefiles on Linux and macOS to allow you to change, play with the sample application. And we provided also already built to already built, sorry, to allows you to run it directly and check quickly things if needed. So I will run the sample application. I use a small .bat file. It doesn't contain any specific things. It just sets some Qt things and it goes on the up folder just to be on the same folder as the DLL. So it will find it. Okay. So I will run the sample application. As you can see, it's not something very nice. It's really for teaching purpose and for developers. The first thing to do with our API is to call one function, which is initialize kernel. This function will do some core technology license checks and prepare our CAD kernel to load a CAD model. So this is done by this button on the sample application. Then, just before loading a CAD file, you can prepare some options regarding your needs. They are loading options. So we can load topology information. I will explain what they are in few minutes. You can also ask 3D kernel IO to use some healing algorithm that will complete the topology if you are, for example, loading some old IGS files which doesn't contain topology, or maybe if they contain some partial topology which is not enough for your needs. And there is also another algorithm which will really destroy or ignore all the topology of a model you will load, and it will do some recognition to create its own topological information. Then you can load, for example, some hidden objects. Hidden objects most of the times are the construction geometry, or maybe if there is some hidden things on purpose for the user. If you load some big assemblies like a full car or something like that, it can take some time to load such data, which is normal. But in that case, and maybe if you or your customer are not interested in loading the full huge assembly, but maybe loading only a partial things and partial portions of an assembly, you can enable this loading option. Thanks to this, we are going to load only the assembly structure. That means we are going to load all the assembly, the sub-assembly, sub-assemblies, etc., with all transformation matrices and instances, but we are going to stop the loading when we will encounter a part in the assembly structure. Hence, for example, with that load assembly structure only options, you will be able to load in 10 or 15 seconds a 4 GB assembly, which contain a full car with its engine, for example. However, you won't get the geometry. But thanks to this, you will be able to show the assembly tree to your customer and allow your customer to pick maybe few parts to allow them to load them directly without loading the rest. And thanks to this, it can be a lot of time saving. We have also some other customers who have done something else with this. For example, they do a first loading of an assembly with this option, and they store in their data structure the all referenced parts, and they also store the assembly structure. And then they will do some background loading of the parts to do some streaming effects when loading an assembly in their CAD software. We have some other options maybe that are a little too technical for this demonstration. We have the load features option. So David talked about this briefly. What we call features on our side is the full historical construction tree, because in fact, it's a CAD file like a CATIA-V5 or NX or Creo file contains an historical construction tree, which are the operations that have been made to build the geometry. and build the model. For example, you start with a sketch, then you extrude the sketch, then you drill some holes, then you do some chamfer or things like that. This is the historical construction tree. By default, on our side with 3D Kernel.io, we avoid loading such kind of data, and we really go into the CAD file to bring the geometry and only the geometry. However, we are also able to load the full feature tree from a CAD file when it's supported, and hence you will really get all the operations. That means all sketches with their constraints, all operation, drilling, extrusions, revolutions, etc., etc. So, as you can imagine, reading more things require more time and more memory, etc. That's why by default on our side we don't load them, but you can load them. It will take more time. But if you want to get more information, it will take more time, of course. So really, regarding your needs, it can be interesting for you to load such things. I will just add one thing on this. As we have the full historical construction tree, we also have the link between an operation, that means, for example, a hole, and all faces associated in the geometry to that feature. For example, if you browse a hole feature, you will get in the geometry the faces of the hole, which should be 2 half cylinders and maybe a plane at the bottom or a cone, etc. CATIA v5 have a specific container which is called a geometric set. When a CATIA v5 model contains such a geometric set, it has a specific assembly structure. It's not in fact an assembly structure, it's really a part structure, which can have some hierarchy, etc. If you enable this option, you will be able to get such hierarchy when loading a CATIA v5 file. Then you can load some additional metadata attributes. You can load annotations, which are PMIs, GD&T, etc. on supported formats. If you just want to load some preview, for example, to do a first quick load, you can enable load tessellation only. In that case, we are going to avoid loading any BREP exact geometry, and we will try to load only the triangles to do the display very quickly. It can be also very useful if you handle JT files, because JT files can contain both triangles and exact geometry. So depending on your needs, you can enable this option. And we can also load some publications or composites data. At the moment, I will just keep the default options, and I will load a small demonstration file I had here. So it's a CATIA v5 file, which is very simple. I made it in CATIA, so as I'm not a great designer, it's really a simple cube with some holes, and I have put some colors. So this is a rendering you can see in the sample application. Now I will show you something very important. Most of CAD files doesn't contain triangles for displaying. They contain exact geometry. That means they contain plane definition, they contain cylinder definition, etc., etc., sphere, cone, torus, etc. Sorry. And they also contain some trimming curve, because all such kind of surfaces like plane, cylinder, sphere, cone, etc. are infinite in the geometry. And so we have to trim them with trimming curves, which are the black lines you can see here. Then the second thing, which is very important and very interesting in CAD, are the topology information, because most of recent CAD files contains topology information. The topology is the information of neighbor between surfaces. For example, in gray here we have the plane of the cube, and in green here we have a cylinder. But this is really a cylinder which have no relation with this cube. And thanks to the CAD formats, we have the information with the topology information that the black line here from the cylinder is neighbor to the black line here from the plane. So yes, in fact, you see only one black line here or here, but inside in the memory there is two. There is one per surface. And here, for example, I will just rotate a little because with movement, in 3D movement, we see better the 3D. Here, for example, there is the black line of this half cylinder and there is a black line of this half cylinder. Now, we have some powerful tessellation algorithm that are able to compute triangles from BREP. And there is something very interesting for most of our customers. It's we are able to use the topology information to produce a very nice and watertight triangulation. I will just show you the triangles in mesh view. As you can, I will just rotate a little so to find an angle in which we can see better. Yes. So as you can see in green here, all the vertices of the display have exactly the same X, Y, Z coordinates between the green cylinder and the gray plane. Hence, even if the tessellation is not very precise, or I mean, it is precise because each vertices here are exactly, exact in terms of mathematical exactness, are exactly on the surface. But there is not enough triangles for the human point of view to see a cylinder, because you can see here all the triangles. And this is something not very nice, but at least they are watertight because all vertices between neighbor surfaces have the same coordinate. Now I can ask our CAD kernel to compute a more fine tessellation. For example, I will put, there are the criteria on the top right of the sample application, and I will put, for example, 5 degrees and ask to compute new triangles. And now, as you can see, it's far better. If I do a mesh visualization, you will see there is far more triangles. I will just go back and you see there is less triangles. But anyway, they are nice. Now I will just do quickly something. I will load the same file without topology information. And as you will see, it's the same cube, but we don't have any neighbor information. And hence, we have exact triangulation, but there is no relation between neighbor surfaces, and so it's not so nice. If I do a mesh view, for example, you will see that the green vertex is here, while the gray vertex is here, and hence it's not watertight. So this is something important that will lead me to show you some repair algorithm. I will just display the what we call the check results, which will display the geometrical quality, which can be imprecisions and can be free edges. A free edge is an edge which don't have a neighbor. So as you can see here, the full model have free edges everywhere. That means there is no neighbor information. So what I will do is just call our skewing algorithm, which is able to find in a very optimized manner all possible topology. So I will skew the model, and now, as you can see, we have found all things. So it's a demonstration CAD file. It's already a perfect geometry quality CAD file. That's why the skewing algorithm has worked perfectly. But if you have an old model with some problematic geometry, it may not work as good as this. So now, as you can see, we still have the old tessellation. Mesh. So now I will ask 3D kernel IO to compute new triangles, which has been done automatically when I switched this. So I'm sorry, but now, as you can see, there is again a very nice tessellation. So we have some healing algorithm, stitching algorithm, sewing algorithm. If it's something you are interested in, you can ask us to do some specific demonstration. Now I will just speak quickly about our exact geometrical conversion mechanism, which is also something very powerful. We are able to convert any mathematical surface into another one as long as it's mathematically in the tolerance. For example, if you load a full NURBS model, and if you want to try to get some better analytic surfaces like sphere, planes, cylinder, cone, we will be able by a mechanism of priority to convert surfaces into another type. So if you want to, for example, to convert a model into full NURBS and full planes, you just have to set a high priority for planes and a non-priority for all other surfaces. And thanks to this, if now I convert the model, all surfaces that can be converted to planes will be converted to planes, and all other surfaces will be converted to NURBS. And it works in both ways. That means it's also possible to, from a full NURBS model, to get such kind of surfaces, which can be very interesting because NURBS are easy to deal with, but they are not precise and they are a little heavy in terms of memory and computing thing. And besides, it's not possible to do exact mathematical computing on NURBS surfaces. It's always approximation. So there is such kind of conversion. We can also convert on faces the geometry, for example, to create, if they doesn't exist in the original CAD file, to create a 3D representation of co-edges. Because at the moment, our CAD kernel is fully parametric. That means when we load a CAD file, we will create, if they are missing, all parametric UV curves for all surfaces. And if they contain some 3D curves, we also store them, but we don't use them for computation. However, you may have a use of such 3D curves on your side, and that's why, if they exist, we provide them. Most of the time, on the format that supports them, they are partial. For example, IGS or Parasolid format contains 3D curves, but not everywhere. And thanks to our conversion mechanism, we are able to create such missing 3D curves and provide them to you. I think it's already a good start for everyone who could be interested in our API. I will just do something at the end. I will export this model into a XML dump. So I just have to do this. I just have to put .xml, and in the sample application source code, it will detect you want to dump XML data, and it will call the big XML source code I just shown previously. And now you have a XML dump, and if I open it in a text editor, you will see how is organized our data structure. So it's a very simple model. We have an indexed array of colors. We have an array of material which is empty because on this model there is no material. There is a lot of attributes we can get from CATIA v5. So there is some UUID, there is some original attributes like names or things like that. For example, original name attributes are exactly the name you can see in the CAD software, the original CAD software. So in that case, CATIA v5. And then this is the main component, which is a part. This component contains one body, and that's all, because it's a very simple file. If I open the body, it also contains some attributes. For example, here you can see an original ID attribute, which is something also very important because it's really the ID of the entity in the CAD software. So in CATIA V5, for example, and it is stored in the CAD file. So it can be used as a persistent ID, for example, for a company who needs that. Okay, and the body contains some one or more shells, and each shell will contain some faces. So as it's a cube, it will contain 6 faces plus, sorry, all the faces of the holes we have seen previously. I will just put this in an edge of the screen. Okay, etc. So for example, if I take the first face, it's an exact faces, so it's not a triangulated face. So if you load the JT file, it will be a triangulated face. It contains some attributes. It will contain the exact BREP data. So that means in that case, it's a cylinder. So it's one of the hole. You will get its axis, you will get its radius, etc. And you will get all the trimming co-edges. Okay. And then, for example, if I take another face, I will just try to take a plane somewhere. Yes, here. This face is a plane, and for the plane, you will get, for example, the origin and a normal of the plane. So you have a mathematical exact plane definition. And then you will get some co-edges which are trimming the plane to show you this nice cube. Okay, and now, for example, so unfortunately, I don't have this right now under my hand, but if you load a similar cube stored in a Creo and in NX and in a SolidWorks file or even STEP or IGES, etc., and if you dump it in XML, you will get nearly exactly the same XML dump. Some things will change. For example, some attributes, some name will change, but you will get exactly the same structure. That means you will get the component, you will get one main body, which will contain one shell with multiple faces, etc. So that's why I explained at the beginning that our unified data structure is something very important in terms of cost saving, etc. I think as a first overview, it's already a nice demonstration. I will give the hand to the next person, and if you have questions, don't hesitate to ask them, I think at the end of the webinar. Thank you.